Hello everyone, let's start with week 5 theory. We'll be covering functions here. So the very first type of function we have to study is one-to-one function, though the definition was covered in the previous lecture also. So we have defined a function f from a to b, where a is the domain of the function and b is codomain. And if a function is one-to-one, it means that whenever your x1 and x2 are equal, the value of f of x1 and f of x2 will also be equal. And if your x1 and x2 are not equal, then f of x1 and f of x2 will have different values. So let's see some examples. The very first example is of mod x. So how do we check whether it is a function or not? So we do vertical line testing for this. So we draw a vertical line on the graph and check the points of intersection. If the vertical line intersects the graph only at one point, that means yes, it is a function. But if there are more than one point of intersection, that means it is not a function. Then how do we check whether the function is one-to-one or not? So for this we do horizontal line testing. This is the graph. So we'll draw a horizontal line. If there are more than one point of intersection, that means it is not a one-one function. So for checking whether it is function or not, we do vertical line test. If there is only one point of intersection, that means yes, it is a function. And for checking whether the function is one-one or not, we do horizontal line testing. We draw a horizontal line and check the point of intersection. If there are more than one point of intersection, that means the given function is not one-to-one, and all the one-to-one function are reversible function. Next example is f of x is equals to x. Now this is a given function. Now we need to check whether the function is one-to-one or not. So we draw a horizontal line. So you can see that there is only one point of intersection. That means the given function is one-to-one. Similarly, for f of x is equals to x cube, you will see only one point of intersection. That means this is also a one-to-one function. Now you are given with a theory, you can just go through it. Next we have exponential functions. So how do we define an exponential function? It is always written in the form of a raised to power x or a raised to power r, where a is base and r is exponent or power. A is always greater than equal to 0 and it is never equal to 1. And your r is a real number. Most of the times we say that we define it as a rational number. So a question arises whether your r can be irrational or not. So r can definitely be an irrational, but the only problem is will not get a constant value, means the value will be recurring. So it is totally defined for real number also. And why we say that a is not equal to 1? Because 1 raised to any power will give you 1. That is why your base is never equal to 1. Next, there are some laws of exponents. For example, we are multiplying two numbers whose base is same and powers are different, so those powers will be added. Now let's suppose you're given a number raised to any power and that whole has a different power, so both the powers will be multiplied. Similarly, if two numbers are multiplied and the product of them has a power, so that power will be divided to, means given to both the number, and 1 raised to power of anything will give you 1. If your power is negative, it can be written in this form. Then base raised to power 0 will give you 1 and 0 raised to power 0 is undefined. This we have studied in limits class 11th. So this is the definition. Now let's see some examples. Use some graphing tools for these functions. I'll do one. 2 raised to power x. This is our function. We know that domain of exponential function is r, all real number, and range is from 0 to infinity. And we know that when a is greater than 1, this is how the graph looks like. And end behavior will be minus infinity to plus infinity. Minus infinity here and plus infinity. So these will be end behavior. And yes, this is an increasing. How do you get whether the function is increasing or not? So we'll put the value of x. If your x1 is greater than x2, x1 is greater than x2, and f of x1 is also greater than f of x2, that means your function is increasing. And all the 1 functions are increasing functions. Odd. So this is how it is done. There are some more examples, you can go through it. So let's just summarize. If your function is a raised to power x, and when your a is greater than 1, domain will be any real number, range will be any positive number, that is 0 to infinity. There will be no x-intercept, y-intercept will be from 0 to 1. And this is how the graph will look like when a, your base, is greater than 1. And it will be an increasing function. By the graph only you can see that it is an increasing function. Similarly, when your a lies between 0 to 1, domain will be same, any real number, range will be any positive number, no x-intercept, and it will be decreasing function. Y-intercept will be 0 to 1. Next we have natural exponential function. That means the function which has natural log base e, and its value is 2.71. We take 2.71 for all the calculations and all. So from limits we are totally aware of this, that 1 plus 1 upon n raised to power n tends to e when your n tends to infinity. This whole will be 0. This is raised to infinity, so you'll get e. This part is covered in limits and this will not be asked. I've already told you I'll be focusing more on the topics which will be asked. So you'll get different values of e. While putting different values of n, you can go through this table, though this is not important. Yes. So whenever you're defining a function with natural exponent, it is given as this, e raised to power x. Domain will be again any real number and range will be from 0 to infinity. E is definitely greater than 1, its value is 2.71, and y-intercept is again 0 to 1. X tends to infinity, function goes to infinity. Okay. So these are very basic things, you can just go through it, not very important again. This is a graph of e raised to power x. Everything is already covered in the previous classes, so not going through these things. We have an example, let's discuss. Let R be the percent of people who respond to affiliate links under YouTube descriptions and purchase product in T minutes, and it is given by this, okay, this equation. So the first question asked is, what is the percentage of people responding after 10 minutes? So this is the equation given. R is the percent of people and T is time, which is given in minutes. So you're asked that what is the percentage of people who respond after 10 minutes? That means you need to find the value of R when your T is 10. So just simply put T as 10. You'll get the percentage, that as 36.46. It's an easy numerical. Next, what is the highest percentage expected? So this is your given equation. This value e raised to power minus 0.2 into t, it will never exceed 1 because t is time, it will always be positive, and positive into negative is negative. So this e raised to power minus 0.2 t will tend to 0 when x will tend to infinity. It's very obvious. It is covered in the notes, you can go through them. This means that whether you multiply this whole term by 100 or any other number, this always will give you 0 at the end. So just do not consider this. So RT will be 50. So the highest percentage of people you can expect is 50. Next, what is the third question? How long it takes before RT exceeds 30? Okay, that means you are given RT, you're given the percentage of people, now you need to find the time. Just simply put 30 in the place of RT in the equation and solve it, you'll get the time. Okay. So what you got after solving this? So you need to stop here because right now we do not have any way to see what t will be like this. So no analytical way is not possible. So we'll go with graphical way this time. Okay. So let's make the graph e raised to negative power. So the graph will be like this. So by graph now you will see that when your RT is 30, you'll plot RT on y-axis and time on x-axis. So by graph you'll check when your RT is 30, what value you're getting? It's marked as 8. So your answer, your time is 8 minutes. Hope it is clear. Next we have composite functions. What is a composite function? The functions are denoted like this. Like I'm saying that we have a composite function f of g of x. So either you can write it like this, f fog like this, you can pronounce it as fog, or you can write it like this. So the domain of composite function is set of all x such that x is domain of g and g should be domain. Yes. If the function f is defined from x to y and I am asked to write a composite function f of g, that means my g will be defined from y to. So my g should be in the domain of f. So if I actually defined g as x to y, not f. It was my bad, I said f as x to y. No, I'm defining g as x to y. So my x is in domain of g. So when I'm defining a composite function, my g will be in the domain of f. Okay. Let's see with some examples. It will be clear. Suppose you are given a function f of x as 3x minus 4 and g of x is as x square. Now you are asked a function g of f of x. So g of f of x. So how do we find g of f of x? Just replace x with f of x. So what was your x? X square. So instead of x square, we write f of x square. What is the value of f of x? 3x minus 4. So 3x minus 4. Instead, you can do this also. You have replaced x as your f of x. Now, you can put the value of this function first and then the final value of g of x. You can go with any of the methods. So there are more examples given. Go through each of them. Next, we have one assignment of composite function. I'll go with this question. Though it is easy, still I'll go. My f of x is this and g of x is under root of 2x plus 5 and I am asked to write composite function f of x and g of x. I'll do f of x. You have to do g of x as your task. So again, just replace. You are asked f of g of x. So instead of x, put g of x everywhere. Instead of x, put g of x. And it's very easy. Just open this square, multiply this bracket, you will get the answer as 20x plus 75. It's quite simple. Yes. So next we talk about the domain of composite function, how it is defined. Suppose I have defined a function f of g of x, and if x, there are basically two rules, and if my x is not in the domain of g of x, it should not be in the domain of f of g of x also. Simple. And if my x belongs to f of x, that means it lies in domain of f of x but not in g of x, but not in g of x, then it should be in the domain of f of g of x. I'll give you one example, then you'll get it. Yes. Now you are given two functions, f of x and g of x. F of x is 2x minus 1 and g of x is 3 by x. You are asked a composite function f of g of x and its domain. So f of g of x, just replace x as x by g of x. You'll get function as this, 2x upon 3 minus 1. This is your composite function. Now how will you find the domain? See, when you're putting x as 3 here in f of g of x, your function will be undefined. So means your denominator will be 0, function will be undefined. So 3 is excluded from your domain. It's very clear. Next, if you will put x as 0 in g of x, what was your g of x? 3 upon x. If you put x as 0, your function will be undefined. That means your domain is not even taking 0, and your f of x is not taking x as 1. It will be not defined. That means your x should not be 0, your x should not be 3. Rest, it can take any of the values. Now please clear. Again, you are given some questions, just go through these. Next, we are given with inverse functions. So if I have defined a function f from a to b, like I'm saying that I have defined a function f from a to b, and I am asked to write its inverse. So only my domain and codomain will be swapped. Suppose a is domain of my function f, then for f inverse, my a will be its codomain, and b, if b is codomain of function f, for its inverse, b will be its domain. This is what it is written here. So how do we find inverse of a function? Suppose you are given any function like g of x as 4x, and you are asked to write its inverse. So just take this function as y. Yes, here. Take this function as y and find the value of x in terms of y. This will be your inverse function. This will be your inverse function. And what is your identity function? If your g inverse, like g inverse of g of x gives x, that means that function is your identity function. And suppose you are asked to verify, you're given a function g of x and you're given its inverse also, and you're asked to verify whether they are actually inverse or not. It means you need to check identity function. I'll give one example. First cover this page. Yeah, this part I have already told you that my f inverse f of x is x for all x, which is domain of x and range of f inverse. And if I am writing f of f inverse x, so domain and range will be swapped, nothing else. And for every one-to-one function, f inverse is defined. So I have covered everything written in this page. You can go through it. And yes, there is a warning. Your f inverse does not means 1 upon f. Never ever confuse yourself with this. Yes, this was I'm talking about. Suppose you are given with two functions. G of x is x cube and g inverse is also given to you as under root of x cube, and you are asked to check whether these functions are actually inverse of each other or not. So what you will check? You will check g inverse g of x and g of g inverse x. Both should be identity function. So g inverse g of x will replace this x, will replace this x as g of x. So this is your g inverse. Instead of x, you'll write this. So what does it mean? It is basically x cube raised to power 1 by 3. This will be cancelled. It is giving you 1. And second, you will check for g of g inverse x, this. So your g was x cube. Instead of x cube, you will write this. Now it was cube. So it is again giving you identity function. Similarly, you can verify this also. This is your task you have to by your own. Next, I think, is graphs. Yes. Now, graph of f and f inverse. If a comma f of a is on a point on graph f, then f of a comma a must be a point on graph f inverse. Suppose a function is defined when I'm putting x as a input as a, I'm getting result as y. It is function f. So when I'm defining f inverse, if I put y, I should get a as output. This is already covered. So graph of a straight line. Let's start with the very basic one. Graph of a straight line, y is equals to x. Suppose this is a point. It is on your graph f of x. So where will this point be, this point on f inverse? This is a question asked to you. Suppose I'm having this point a comma f of x. So its inverse will be exactly opposite, and the values of x and y coordinates will be swapped as well. So it will basically give you a reflecting graph. This will basically act as a symmetric line. Now the graphs are symmetric across the lines. Next, we are asked with domain and range. You can definitely do this. This was all about week 5. I hope everything is clear.